Okay, so here's lesson 6.7. This is the homework. This is not the practice work, but this is kind of give you an idea how to do the practice work if you're working ahead here. So I went ahead and just started just doing did all the measurements without off video. I think you guys know how to use a protractor and a ruler by now. I wanted to save some time, but I did want to show you how I overlaid the measurements so to avoid confusion. It didn't really come out. Maybe if I turn the light on. If I turn where's the light button? It makes it a little better, I guess. Right, so can I make it brighter? No, it's just on or off. Okay. Alright, so you can see that I have like a pink and an orange, and then these are blue for the angles, right? So my orange triangles, my little triangle here, and my pink triangles, the bigger triangle, and it encompasses the orange triangle as well. Okay, so therefore the line segments of that triangle are encompassed, of the orange triangle, are encompassed by the pink triangle's line segments for these two sides, but not necessarily for these two sides. And for these similar triangles, you can see that this reflexive triangle, or angle here, this angle K, is shared for both the orange and the pink triangle. I guess it's more accurate to say this angle with the vertex of K is shared between the two triangles, because it is shared between triangle P, K, Q, and triangle J, K, L. Right, two different triangles, same vertex. It is shared by the reflexive property. Okay, that's the only two things that are really shared by the reflexive property here. All right, so those are all the values, and when I measured in the table, I transposed those values onto the drawing, as you should, to give yourself a more clear picture of what's going on. Right, so this 3.5 is a part of the 6, and this 4.6 is a part of this. So with any part of these, you can figure out the ratio of these things. So over here, I'm going to figure out a ratio of this one, and a ratio of this one, and a ratio of this one. Alright, so I'm going to figure out, I'll just do a ratio of my little one to my big one. So it's going to be less than 1. Right, so a little ratio of my little one to my big one, or my orange to my pink, is going to be 3.5 to 6. Right, and my over here it's going to be 4.6 to 8. And you're going to find that these ratios are all going to be come out to the same value. And over here is going to be 5 to 8.5. 8.5. I'm just going to calculate this to a decimal format. So 3.5 divided by 6, unless it comes out to a nice neat fraction, 7/12. Okay. Equals 7/12. 4.6 divided by 8, that's a 6 divided by 8 equals 4.6 divided by 8 equals, okay, let's do 6 divided by 3.5 again. Oh, I did it backwards. 3.5 divided by 6 equals that. Okay. 7/12. 6, approximately 0.58. They may have used rounded numbers in theirs. 4.6 divided by 8 equals approximately 0.58. Yeah, that's the thing about rounding numbers here. When you go to decimals, it's the thing about, and then 5 divided by 8.5. It's approximately 0.58. Okay, so that's the different ratios between this one and that one. Okay, so the ratio of JK to PK, that's JK to PK. That's the big one over the long one. That's just that 3.5 divided by 6, and I'm going to invert that. That's 1.71. It doesn't tell me what to round it to. It's about, so there you go. And then this is that 4.6 divided by 8 for this next one. KL. K as the big one divided by the little one. So I just did the opposite of this one. It's little divided by big. So that's 4.6 divided by 8. And you could have just inverted that too. I guess 1.74. So, and then you could say that, and then the other ones are, and you could say over here, the next ones are, and it says JL and PQ. It's JL 8.5 divided by PQ is 5, and that's 1.700. 1.700. And if you did mine, 5 divided by 8.5, and then just inverted that, it's again 1.70. Okay, so the corresponding sides of KJL and JKQ, let's see, are, let's say triangle JKL, and alright, so JKL and JKR. Okay, so this is saying that JK and PQ, JK and PQ, pause this for a second and think about what they're asking here. I skipped a question here. The corresponding angle of K, J, L, and Q are, well, K and K, obviously. We talked about that. Angle K and angle K. And we had angle J and angle P. Angle J and angle P. Angle J and angle P, and we had angle Q and angle L, angle Q and angle L. All right, so that's that one. Now going back to the one I was thinking about, see what they're trying to ask me. Well, I guess they're trying to say that the corresponding sides of the big triangle and the little triangle are JK and PK, right? So the big one is, although I looked at the key and I'm not really sure that I agree with this, because they're not, I mean, there's some rounding errors maybe in that, but they could have come up with some better numbers and examples for this one, but okay. Right, so these corresponding side, this is a corresponding side to this one, so JK and PK. So JK to PK, PK. JL to PQ. So JL to PQ. I just can't see what I'm doing. To PQ. And then there's KL to Q, KL to KQ, KL to KQ, KL to KQ. So I don't know. I mean, these are pretty close, but they're not perfect. They could have come up with some better numbers for that, if you ask me. So they're saying that KJL, that triangle KJL is similar to KPQ. KJL is similar to KPQ. I guess similar is close enough, but although the decimals weren't exact, the ratios weren't exact. So I don't know if I would necessarily agree completely with that, but okay. So describe the sequent that could be mapped. I can use a map the big one onto the little one. All right, that's a dilation about point K. Dilation about center point K. I wonder if the key tells you what the scale factor is. Maybe 0.58. What's the key say? Approximately 0.59. Say approximately 0.5. I'm gonna say 0.58 because they just rounded a different way than I rounded. All right. So complete the relationships here. So this is pretty easy, right? So the way you want to do this is you have the PK. This is the orange. The JL. This is the pink, right? So your PK is to this side, right? So the big one of the big corresponding side of this one is your KJ, right? So you get your KJ, and then over here the JL is this length. So the small side of that one is your PQ. Okay, so when you're setting up these ratios, you just say, hey, like this one is associated with this one, and this one is associated with this one. So just make sure your similar size, triangle or polygon, segments or segments are on the same side of the fraction, on the top or the bottom, on the numerator or the denominator. Right. Remember this side, my orange ones are my smaller triangles in this example, and my pink ones are my larger ones in this example, right? So in so in number 8 here, JK is my big pink one, right? JK is my big pink triangle, so its smaller counterpart, the orange one, would be PK, right? QP is its shorter counterpart, right? So the larger counterpart would be JL, right? So there's the relationship there. Pink, orange, orange. Oops, yeah, that's an orange still. So there's a relationship there. Okay, so moving on to the next one here. Now we got KQ, that's orange. KJ, that's pink, right? So it's still gonna be orange on the top, pink on the bottom. So KQ's corresponding pink counterpart is KL, or sorry, KJ's orange counterpart. So KJ's orange counterpart is KP. Okay, and then KJ's KQ's pink counterpart is KL. Right, so that's how you do that one. Alright, so then we have observing at JL, the ratio of JL to PQ. So the JL to PQ is not the same, is not equal to LQ to Q to QK. So this ratio of JL PQ. So this ratio of this one to this one is not the same as this one to this one. Your classmate claims that not similar. Her logic is faulty. Explain why. Well, LQ, so LQ here, LQ is a smaller portion of just this one side of this larger triangle, right? It's nothing. It means nothing compared. It's just a smaller portion of this 8 centimeters, right? In the long run, this like length line segment doesn't mean squat, right? In any of the calculations, right? It is just a small portion of this longer line segment, so it shouldn't be used in any calculations, right? And if we used LQ to QK, where's QK? Yeah, that would just be like almost like a dilation calculation, kind of, right? It's nothing. It's just a ratio of this length to that length. It has nothing to do with this triangle to this triangle. This is just a portion of this entire line segment, right? This line segment has nothing to do with this triangle, right? They used the wrong line segment. Now, if they were to do like this minus this divided by this, then that would be fine, but it's super hard. No reason to do that. You already given that statement. So, LQ is not part of or is not an entire line segment of your triangle. Alright, so I hope that helps out for you guys. Hope you have a great day.